In this video, we're going to look at how we can use the TI-89 to manipulate functions in different ways and how we can use a shortcut to help us do this. This will be especially useful when we're doing problems where there is a function that you're doing multiple things to. So let's take a look. First thing we're going to do is we're going to go to the y equals. And the functions that we're going to be using in this example are f of x equals secant of x, and g of x equals 5x squared plus 7x. So let's see how we can enter that in. The first thing you should be thinking about is, well, how do I even enter secant into this calculator? If we go to the keyboard, you can see that there are sine and cosine and tangent, but there is no secant, cosecant, or cotangent. So there are three ways we could go about doing this. One of them would be to type in 1 over cosine of x, because we know secant is 1 over cosine. The second way is we could go to the catalog, which is that button, and then you can see that we have all of the functions. If we jump down to s by hitting the where the alpha would be, you can see that secant is there. But the easiest way to do it is to actually just type in secant using the alpha. So I'm going to do alpha 3, that gives me the s. Alpha division gives me the e, and then close parentheses. And then, of course, I need to put in of x in parentheses, and that's going to give me secant of x. The second function I can just type in 5x squared plus 7x. And now what we've done is we've stored this function in y1 and this function in y2, which means if we go back to our home screen, if I were to type in something like y1 of x, it's going to tell me what secant is equal to 1 over cosine of x. Okay? Be careful here that anytime you use the function, though, you have to put the of x. If I just type in y1, that's not going to work. I'm going to get an argument error because it wants something to be inside that function. Okay, so what can we do with this? Well, the first thing, if we take that polynomial, which here I'll take it in so you can see what it is. y2 of x is 5x squared plus 7x. We could just type in here factor y2 of x, close the parentheses, and it'll factor it for us. So you can do the manipulations of these functions by just typing in y2 of x. Another example, if we go to this screen here, if we wanted to just evaluate what is f of pi over 4, well, going to the calculator, we can just type in y1 of pi over 4, like that, and it'll tell us it's the square root of 2. Okay. We can also, oops, wrong screen. We can take an equation like this, and we can solve that equation. So let's go ahead back to the calculator, and we'll solve that using our solve function. Oops. So we're going to solve y1 of x equals 2, and then we have to tell it to solve for x. Close the parentheses, and you can see, this is a good reminder that, if you get this at n thing, the easiest way to fix that is to put an evaluation and say, well, let's do it from 0 is less than x is less than 2 pi. That is one full unit circle. And then you can see that it'll give us pi over 3 and 5 pi over 3 as our two answers. And we can see if I were to do y1 of 5 pi, pi over 3, that's going to be equal to 2, which is what we were looking for. We can also do limits. And again, what's nice about this is you saw how a little bit annoying it was to type in secant. So here, instead of having to type in secant each time, we can just do y1 of x. So we're doing the limit of secant of x as x approaches pi over 2. And we're going to do it from the positive side, so I'm going to put in positive 1. And you can see that that's going to be negative infinity. So as you approach pi over 2 from the right side, it goes to negative infinity. We can use this to take derivatives. So I can do the derivative, which is here. You can also get it from the menu above. y2 of x comma x. We can put that in, find the derivative. That would be g prime. We could take the derivative and evaluate it at a specific point like pi over 3. So let's do that. I'm going to go back here and I'm going to change that. Oops, not that. y1 of x. And then to evaluate this at a specific point, I'm going to put the evaluation bar, x equals, and it was pi over 3. And you can see that that's going to be 2 times the square root of 3. If I go here, if I wanted to find the second derivative of g, I could do, so we'll delete that, change this to y2 of x, which was g prime, second derivative, put in a comma 2, and you get that the second derivative is going to be 10. We can also do something like this, where they want you to find the function, the derivative of the function, and set it equal to 0 and solve. This would be like finding critical points. You can do this on the calculator. So I'm going to take the derivative of y2 of x, comma x. Oops, and I'm going to go to the beginning here. I'm going to say solve. I'm going to say that this equals 0. I'm going to solve it for x. And you can see it's saying, when does the derivative of y2 of x equal 0? It happens exactly at negative 7/10. Okay. We can also do integrals. So if I wanted to take this integral, for example, I can do that. I can say the integral of y2 of x, comma x, from 0 to 5, and you can see that it sets it up, the integral from 0 to 5 of the function, and you get 1,775 over 6. If I wanted to, I could figure out what that is approximately by doing that. Okay. So one last type of example I want to do, let's take a look at this new function. So I'm going to go ahead and enter this in. I'm going to go clear out the two functions that I have in here and put in 3x to the 5th minus 5x to the 3rd plus 2. And double check that matches what I wanted to do. And so sometimes what we do, maybe you remember from Calc 1 where we would graph functions. We take the derivative and we do a bunch of things with that. We take the second derivative, we do a bunch of things for that. What I'm going to do is, for my y2, instead of typing in a function, I'm going to type in the derivative of y1 of x, comma x. And then for y3, that's going to be the derivative of y2 of x, comma x. That's basically going to be the derivative of the first derivative, which is the second derivative. So what we have is a function, a derivative, and a second derivative. And now when we go back to the home screen, we can do things like find the critical points. The way you would find the critical points is you would solve y2, remember that was the first derivative. Oops, not that. Forgot to put in the equation. Set that equal to 0, that's the derivative equaling 0, and I can solve that, and it'll tell me there are critical points at negative 1, 0, or 1. I could find points of inflection. I could say, oops, I shouldn't have deleted all that. Solve y3 of x equals 0, comma x, and that's going to give me my possible points of inflection. Maybe you remember that once you found the critical points or the points of inflection, you had to make a sign chart and plug in numbers in between. Well, if I want to plug a number in between negative 1 and 0, I can do y2 of negative 0.5. And that'll tell me that it is negative something, so then the function is decreasing there. Okay. And so this is a little bit of a shortcut where you can use the equations, the functions, plug in the derivatives here, and then if you had to do this for a second problem, you could go up here and delete that function and put in a different function and do the same thing again without having to find the derivative and find the second derivative. One last thing, if you were asked what is the derivative, I should have done this while this was still in there. Let me put that back. You can always just type in y2 of x, and it'll tell you what the derivative is. y3 of x tells you the second derivative. Okay, so this is just a little bit of a shortcut to finding different things you can use the calculator for when you're dealing with functions. If you assign those functions in the y equals, it's a lot easier to manipulate, so you don't have to keep typing over and over again, and possibly messing up, an exponent or something, or a sign somewhere if it's pluses or minuses. This will save you the trouble. You can just double check that you have the function typed in correctly here and get the derivative in the second derivative. And don't have to worry about typing that in over and over again, especially if you're doing multiple things with it. A lot of times you'll get a problem where they give you a function and they want you to find the critical points or find the antiderivative or find the area over a certain period of time. So this will save you that trouble. All right, that is all for this video.